Hi, thank you for your interest in LPCXpresso. Today we will go through a short introduction to the LPCXpresso tool and software. LPCXpresso is a new low-cost development platform available from NXP. The software consists of an enhanced Eclipse-based IDE, a GNU C compiler, linker, libraries, and an enhanced GDB debugger. The hardware consists of the LPCXpresso development board, which has an LPC link debug interface and an LPC ARM-based microcontroller target. LPCXpresso is an end-to-end solution enabling embedded engineers to develop their applications from initial evaluation to final production. Before the LPCXpresso IDE can be fully utilized, it must be activated. To activate it, first run it, and then click OK on the unregistered warning dialog. Go to the Help menu, select Product Activation, and then Create Serial Number and Activate. A dialog will appear that has the serial number for your individual copy of LPCXpresso. Please click OK. You will be taken to the LPCXpresso activation website. Click Send Me My Activation Code on this website. Once you receive the confirmation screen, the activation code has been sent to your email address. When you receive a new email, open the email, then select the activation code using the mouse. Now, copy the activation code to the clipboard. Return to LPCXpresso, go to the Help menu, and then select Enter Activation Code. Now paste the activation code that is in the Windows clipboard and click OK. You should receive a dialog that says that you now have activated a full license for LPCXpresso. You are ready to start using LPCXpresso. IDE Overview. Now we are going to briefly describe the components of the LPCXpresso IDE screen. The overall layout of the windows on the screen is called a perspective. LPCXpresso uses one perspective called Develop. Making up the screen are many smaller windows displaying different types of information. These smaller areas are called views. The on-screen layout of the perspective and views, a list of the currently open files, a list of the currently open projects, are all saved in the current workspace. An LPCXpresso project contains .c and .h files, and all of the compiler settings. The workspace information is stored in a folder called .metadata. Workspaces themselves do not contain important data or settings. They should not be put under source control or sent to other developers. One of the handiest views in LPCXpresso is the Quick Start panel. The Quick Start panel is a collection of common actions. The first action most new LPCXpresso users will need to use is Import Example Projects. To import example projects, click the Import Example Projects button, then click the Browse button in the Import dialog. Browse to the example project zip file for your LPCXpresso board. For the board that we are using today, it will be in the LPC13XX directory underneath the LPC1000 directory. After selecting the zip file, click Open, and then click Next. You should see a list of all of the LPCXpresso projects in the zip file. Notice that they have check marks next to them. If you would like to import only some of the projects, clear some of the checkboxes. In this case, we are going to import all of them. Click Finish. OK, now LPCXpresso has finished importing the projects. What has happened under the hood is that LPCXpresso has extracted the project files from the zip archive and put them into the workspace directory. It has also scanned for symbols and dependencies. The default workspace folder is in your home folder under My Documents, LPCXpresso \workspace. Now let's take a look at the Project Explorer view. The Project Explorer view here on the upper left is where you go to navigate through your code. At the top level, it lists all of the projects that are in the current workspace. Within each project, it lists all of the files that are needed to build that project. A project in LPCXpresso is different from a project in other IDEs. Each LPCXpresso project is attached to a directory on the disk, and the project mirrors the files on the disk. To add a file to a project, copy it into the project directory, and LPCXpresso will show it in the Project Explorer and include it in builds. I have added a text file to the source directory inside of the Blinky project on the disk. It may be necessary to choose Refresh in the IDE to update the project. If you drill down past the file level, LPCXpresso will show you all of the other files and symbols referenced by that file. For instance, drilling into timer32.c shows that it includes LPC13xx.h as well as timer32.h. It also shows all of the functions that are declared in the file. Most operations that work over a whole project can be accessed by right-clicking on the project name. For instance, if I right-click on the Blinky project, I can choose Clean Project. One nice trick that I've already demonstrated is how easy it is to bring up a Windows Explorer file browser for your current project. All that is necessary is to click on the project name in the window border at the lower right. It is also possible to bring up a command prompt if you are more familiar with the command line. Just hold down the Control key and click the project name. If you would like to see a datasheet for the currently selected part, just click the part number located in the lower right of the window border. If you would like to change the currently selected part in LPCXpresso, hold down the Control key and click the part number in the lower right border of the window. This dialog will allow you to change the currently selected part. Okay, now that we have some projects set up, let's start editing some code. We're going to start out with editing the Blinky project. Let's navigate into the Blinky project and open blinky_main.c. LPCXpresso has a number of productivity-boosting interactive coding features. For example, if I hold the mouse pointer over a variable, a tooltip will appear that displays the variable declaration. It shows me the variable type as well as the initial value. This variable is in timer32.c, and this project has not been compiled yet. Nevertheless, LPCXpresso has already built a database of all of the variables and functions. This information updates in real time each time files are modified, so it remains useful even if you are in the middle of a big rewrite and you haven't been able to completely compile your code for several days. The next thing I would like to demonstrate is LPCXpresso's autocomplete feature. Let's say that we want to add a brief delay before the LED starts blinking. We will do this with a call to a delay function in timer32.c. I think the function name starts with the word delay, but I am not sure what comes next. I will navigate into blinky_main.c and type the word delay and then type Control Space to autocomplete. Notice that LPCXpresso completes the function name and then puts up a tooltip that shows the function prototype, so I know what parameters are required. In this case, I have to specify a delay length in milliseconds. If multiple functions match the prefix, this could happen if there was a delay 16 in this project as well, then the LPCXpresso IDE pops up a menu of choices to select from. Autocomplete works with functions, macros, and both global and local variables. I'm curious. How does the function delay32ms actually work? If I click on the function name and type Ctrl-G or select Declarations Workspace from the right mouse context menu, then a list of all of the places where functions by this name are declared will show up. At the bottom of the screen in the search window, you will notice that it lists line 38 of timer32.c. This is the function prototype for delay32 and also where the code is for the function. This also works for variables as well. There is another option, References Workspace. This will show where a function is used in the entire workspace. Wait a minute. I think I would feel more comfortable renaming this function to the Dutch word for delay, vertraging. To do this, I am going to use the LPCXpresso refactor feature. First, I will make sure that the item I would like to rename is selected. Then, I will choose Rename from the refactor menu. In the refactor dialog, I will put in the new name and then select the scope. I only want to change the Blinky project, not other projects in the workspace. I will change the name everywhere, even in comments and in macros. I will click Preview to see what changes will be made. A warning is provided that a word in a comment is going to be changed. The issue with this is that the comment might specifically refer to something and the compiler cannot tell, the IDE cannot tell whether it is actually a function or some other use of the word. But we're going to safely assume that all occurrences of delay32ms in comments can be changed. The next step will be the LPCXpresso IDE will show all of the changes that will be made in a side-by-side view using a diff utility. If these changes are OK, then click the OK button and they will be saved. Now you will notice that delay32ms has been changed to the Dutch word for delay throughout the program. This is not a global search and replace. Other functions with similar names or variables, perhaps you might have a local variable with the same name, will not be changed. Only references to this function are changed. In a large project, this could be an important savings of labor. I am having second thoughts about all of my edits to the Blinky example. Right about this time, I am wishing I used version control. Actually, I have been using version control. There is a built-in revision control system in LPCXpresso. To use it, go to the Project Explorer, right-click on the file, and choose Compare with Local History. At this point, you will be given a listing of different revision dates. Double-clicking on any of these will show the changes between the previous version of the file and what is currently loaded in the editor. So we can see in the previous revision, the delay 32ms was changed to the Dutch word for delay, and if we go back to the initial revision, we can see that the call to the delay function isn't even present in the file. To close the Compare to Local History pane, just click on the X on the tab. Building. The build process is where the development tool processes source code through the compiler and linker and generates a binary file that can be used for debugging. LPCXpresso generates Elf-Dorf object files and includes tools to convert them into both binary and hex files. Building a project in LPCXpresso is easy. The first step is to make sure that the project is currently active. The most foolproof way to do this is to click on the project name in the Project Explorer view. Notice that the current project name is displayed in the status bar at the bottom of the window. The second step is to click Build Project Name Debug in the Quick Start view, or for the Blinky project, we will be clicking Build Blinky Debug. You may also choose Build Project from the Project menu, or you could click the hammer icon on the toolbar. Normally, LPCXpresso selects the active project based on which source file you are editing. This will work great except when you are working with libraries. In this case, you may be debugging or editing code in a library which will change the active project and cause builds to only rebuild the library and not the main project. Again, the most foolproof way to avoid this is just to click on the project name or to open any file in the project to make sure that that project is set active. Sometimes when a project is built, there are errors and it does not compile properly. The LPCXpresso Problems view pulls together all of the errors and warnings from multiple compiles into one location. Double-click on the error to navigate to the source line. Whoops, it looked like I did not give the timer number to the delay function. Let me take care of that right now. Now it is time to debug. We are going to take a look inside the Blinky project to demonstrate running code using the LPCXpresso IDE and LPCXpresso board. As with building, the first step to begin debugging in LPCXpresso is to make sure that the correct project, in this case the Blinky project, is currently active. Now, I will click Debug Blinky in the Quick Start panel, or I could click the bug icon on the toolbar. If this is the first time that you are debugging after plugging in LPCXpresso, then the LPCXpresso IDE will pop up a logo as it initializes the LPC Link JTAG probe on the LPCXpresso board. After initializing the probe, LPCXpresso will download the executable for the currently active project into flash memory. It will then execute through the C startup code and stop at the first line of C code in main. LPCXpresso allows execution control such as step over, step into, resume, as well as suspend, and restart. You may also run to the cursor by right-clicking and choosing Run to Cursor. A shortcut for this is Ctrl-R. Breakpoints can be set by double-clicking in the editor's left-hand gutter. Watch points are also supported. Sometimes you track a bug down to a specific line of C code, but you can't figure out what on that line is triggering it. In these cases, you might need to zoom in further. Click the Instruction Execution Mode Debug Toolbar button. This will open a new view that displays disassembly near the current program counter location. It will change the debugger step mode to step individual assembly instructions instead of full C lines. Sometimes this is just what you need to get to the bottom of things. LPCXpresso has many ways to view data. The easiest one is to hold the mouse over a variable in the code. The current value of the variable will pop up in a tooltip. Variables can also be examined in the Variables view. To add a variable to the Variables view, choose Add Global Variables and then check the variables you would like to see. To examine LPC microcontroller registers, you can either choose the Core Registers view, or to see peripheral registers, you can go to the Peripherals view. In the Peripherals view, pick the system subsystem that you are interested in and check it. This will result in the memory window displaying all of the registers and bit fields for that subsystem. To view raw memory, go to the Memory view and select Go and put in an address. You will then have a traditional hex dump. Thank you very much for taking the time to listen to this brief introduction to the LPCXpresso development platform. If you have any other questions, please visit our technical support forum at www.nxp.com/LPCXpresso-forum, or more quickly, nxp.com/LPCXpresso-forum. Thank you.